With e being a transcendental function and this being a linear function or an algebraic function, we don't really have a way to solve for x. Let's say in here, if you're going to solve for x, you need to use natural log. But then you'd have natural log of this, and to get rid of that natural log, you'd have to use e, and you'd just keep going back and forth like that. So instead, we use Newton's method. With Newton's method, it's not supposed to be two functions, it's supposed to be one. So what I can do is subtract one to combine them. So let f of x equal e to the x plus a 2x minus a 3. And then we use the idea that we make a guess, and after we make a guess, we use the derivative. So the derivative would be e to the x plus a 2. And then the general formula is it's x minus the function over the derivative. You take a guess, plug it in there, take the result, plug it back in there. Take the result, plug it back in there. And eventually, you'll get a solution. So to get a guess, it could say, right here's 1. The graph of e to the x goes like this, grows exponentially. And then this crosses the y-axis right here at 3, and then it goes down at a slope of -2. So as my guess, I'm going to say x equals 1. Okay, so the general expression is going to be the guess, and then plug that into the function. And divide it by the derivative. And whatever you get out, then substitute that back in. So I've got my number one guess is that x equals 1. And then substitute that in. So I'm going to do it this way. Take a 1 and store it as x. And then I can have the calculator to evaluate this expression. X minus an e to the x plus a 2x minus a 3 divided by an e to the x plus 2. So now the calculator is going to take the x, substitute it in, and you get that x number 2 is a 0.636. Now what I do is store that as x. In case you hadn't seen it, the store is down here. So store the last answer as x. And then get this expression back again. Don't type it in again, but get it back by going second enter. That's the last thing that we had. Second enter. So when you put second enter, it gives you the last thing. If you do it again, it gives you the previous thing. And it remembers the last 10 things that you did. So now it's going to take the 0.636 and substitute it in. And we get that x number 3 equals a 0.595. And then store that as x. Second enter, and we're almost there. 0.594. And when you do this twice in a row and get the same thing, you're done. There it is. 0.594. And in case you didn't trust this process or your math, you could always go check it on the graphing calculator, but I'm pretty confident.